So our topic is pumps. So the normal duty of a pump is to lift a quantity of liquid from a low level to the high level or to transfer from one place to another place. The pump must provide energy, so to lift the liquid to required height against the force of a gravity, to overcome the fluid resistance to flow of the liquid through the pipe and the pump itself. So pump is defined as a device which transfers the input mechanical energy of a motor into pressure energy and kinetic energy. Pump is classified according to the mechanical principle involved in transfer of energy, which is a positive displacement pump and a rotodynamic pump. So these are the classification of pump. First is a non-positive displacement pump, another is positive displacement pump. For a non-positive displacement pump, it is a centrifugal pump, and for a positive displacement pump, it is a reciprocating pump and the rotary pump. The reciprocating pump has a two type, one is piston and a diaphragm, and rotary pump has a four type: gear pump, vane pump, lobe pump, and a screw pump. The applications of the pump: the pump water from source to the fields for agricultural and irrigation purpose, in petroleum installation to pump oil, in steam and diesel power plants to circulate feed water and cooling water respectively, hydraulic control systems, pumping of water in buildings, and firefighting. The components of a centrifugal pump. These are a structure block diagram of a centrifugal pump. It will start from the overhead tank it will start from strainer and it will end at the overhead tank. From the strainer, it will goes to the footwall which is control the level of water which will be sucked from the pump. From that, it will go to the suction pipe. The suction pressure will be controlled in the suction vacuum gauge. At that, the impeller is rotate in the clockwise direction, and it will be the pump will be rotating at the anti-clockwise direction. It will be rotating the water in the clockwise directions. It has a curved vanes and a volute casing and the impeller vanes. From that, it has a eye of the impeller. It will be rotating. The water will be then sucked to the delivery gauge of the pipe. The delivery pressure will be controlled by the delivery pressure gauge, and it will move to the delivery valve, and the water is moved to the delivery pipe and finally to the overhead tank. A centrifugal pump has the following main components, that is impeller, casing, suction pipe with strainer and a footwall, delivery pipe. Each parts will be described below. First is impeller. A impeller is a wheel or a motor having series of backward curved rails. An impeller is mounted on a shaft which usually coupled to a motor. The motor provides the required input energy to the rotor to the impeller. Casing. The impeller is enclosed in a watertight casing with a delivery pipe on one side and with an arrangement on suction side called eye of impeller. The main functions of casing are: it guides the water from entry to the exit of the impeller. It helps in partly converting the kinetic energy of liquid into pressure energy. And this suction pipe. The pipe which connects the sump to the eye of the impeller is called a suction pipe. It carries the liquid to be lifted by the pump. To the diagram, it will be shown that the water is under the surface of the pump, and by using the motor, it will be sucked from the ground layer to the upper layer. So it carries the liquid to the lifting the pump. The suction pipe at the inlet is provided with a strainer and a footwall. Strainer and footwall. The function of strainer is to prevent the entry of the debris into the pump. The footwall is non-return valve which allows the flow of water only in upward direction. The valve does not allow the liquid to drain out from the suction pipe. The main function of the strainer and the footwall, which will help the water from moving from downward direction to upward direction and preventing the water in reverse direction, that is upward to downwards. We have already seen the working of the centrifugal pump. It is on a three-dimensional purpose. So it works on the principle that when a certain mass of fluid is made to rotate along the impeller from the central axis of rotation, It impresses the centrifugal head. It causes the water to move radially outwards and high velocity and causes the water to rise to a higher level. The motion of water is restricted by casing of the pump. It results in pressure buildup, which is already seen there. And finally, the deliver valve is cooled and the priming will be carried out. Priming is nothing but the liquid filling in the suction pipe and catching up the level of the delivery valve, so there is no air pockets are left in the systems. If any air or gas pockets are left in this portion of the pump, it may result in no delivery of the liquid by the pump. The pump shaft and impeller is now rotated with the help of an external source of power like motor. The rotation of impeller inside a casing produces a forced vortex which is responsible in imparting the centrifugal head to the liquid. It also creates vacuum at the one eye of the impeller and causes liquid to rise in the suction pipe from the sump of the pump. Sorry. The speed of the impeller should be sufficient to produce the centrifugal head such that it can be initiate the discharge from delivery pipe. The delivery valve is open and the liquid is lifted and discharged to the delivery pipe due to its high pressure. The liquid is continuously sucked from the sump to the impeller eye and it is delivered from the casing of the pump to the delivery pipe. Before stopping the pump, it is necessary to close the delivery pipe, otherwise the backflow of the liquid takes place. And the topic is about cavitation. It was defined as the phenomena of formation of vapor bubbles of the flowing fluid into the region. The pressure of the liquid falls below its vapor pressure, the liquid will vaporize and flow will no longer will be continuous. These vapor bubbles travel into the region of higher pressure, then suddenly collapses on metallic surfaces and the surrounding circuit rushes to fill the cavities of the vapor bubble. The severe rush of liquid causes the development of extremely high pressure. Prolonged cavitation causes erosion and pitting of bubbles, and prolonged cavitation causes severe vibration and noise. And the types of casing. The shape of casing is designed in such a way to reduce the loss of kinetic energy to minimum. Based on the shape of casing, it is classified as volute casing, vortex casing, and diffuser casing. The volute casing is shown in the figure. The cross section is designed to give a constant velocity in the volute of a spiral shape. The centrifugal pump with volute casing around the impeller of gradually increasing area from point A to point B. The loss of energy is reduced compared with circular casing. The conversion of kinetic energy into pressure energy is not possible, so there is only slight improvement in efficiency. The next thing is about vortex casing. The overall diameter of the pump is large compared to volute casing. The increase in diameter will provide an annular space between the impeller and the volute passage. The annular space called vortex chamber, there is a free vortex in which the velocity of the liquid falls as it passes into the chamber from impeller outlet entry of volute passage. Due to decrease in velocity, the pressure increases radially from center outwards. And the last thing is diffuser casing. The diffuser casing is similar to volute and vortex casing, but a diffuser ring with guide vanes is fixed in annular space. The function of guide vanes is to guide the liquid leaving the impeller in a streamlined reversing passage into the volute chamber from where it flows to the delivery pipe. The guide vanes passages have an increasing in cross section which reduces the velocity of flow. Hence the partial kinetic energy is converted into pressure energy. The conversion of kinetic energy to pressure energy takes place in volute chamber of increasing cross section.